Hello there, you're on Vectali, and today we are going to solve the last set of three problems from rotational dynamics. And these three problems is going to give the end for this rotation dynamics series. Welcome to the part 5 of this series. An elastic cord having an unstretched length L, force constant K, and mass per unit length m naught is stretched around the drum of radius r. Okay. You may note here the circumference or the perimeter of the drum is greater than the length of the cord. Let's assume the cord to be as a rubber band. Okay, the rubber band's total circumference is less than that of the circumference of the drum. The limiting speed of the cord due to rotation of the drum, which will allow the cord to loosen its contact with the drum, is v meter per second. Express the value of v square by 11. Okay, they have given some needed quantities. These are required for the calculation. First, let's us think what happens. So we are just let's take a drum which is revolving. Okay, now it's revolving with an angular velocity omega, let's assume, and now we are inserting a rubber band around it. Okay, now what happens, it will be tight, right? Because there is a difference in length. Okay, since it is an elastic of force constant K, it experiences some elastic force in order to come to that particular radius. So that is the limiting condition. The limiting speed is nothing but the limiting condition where the circumference of both this elastic cord as well as the drum is equal. That comes the limiting condition. Now initially at the limiting condition, what happens is there is some sort of extension in the cord. How much is the extension? That's the difference, right? The 2 pi r minus L is nothing but the difference. L is the initial length and this is the final length. So the difference is nothing but the extension. Now let's take a small unit thing in the elastic cord that has a mass of dm. Okay, and this force F is due to the elastic forces. Okay, elasticity of the cord, we get this forces. Okay, and this is from the center a distance r, and this makes an angle d theta. Okay, if you see here clearly, this is rotating, right? As this particular drum is revolving with an angular velocity omega, I'm assuming here the at that particular time there is a velocity v which is r omega. Okay, they are asking that particular v. Fine. So there, if I see from the rotating frame, that is from the elastic cord, we have to use a fictitious force called centrifugal force. I am applying it outwards. So this centrifugal force must be balanced with some sort of force inward. The only inward force is the component of this F towards the center. You may ask where is the normal reaction between these two contact, but what they are telling here is loosen it contact. Okay, that's just at that particular point there will be no normal reaction. Okay, and if you notice here, this is d theta by 2, and towards center you get f sine d theta by 2, and you have two forces, so 2f sine d theta by 2, this is the force acting towards center. You see, sine of smaller angle is nothing but the smaller angle itself, right? So we get 2f into d theta by 2, which is f d theta, which is the net force acting towards the center. Now what is the magnitude of f? They have given the force constant, we have found the extension, so k into delta x, which is k into 2 pi r minus L. In limiting condition, the centrifugal force is balanced by or force component of force F. So F d theta is nothing but dm into v square by r. Here, what is dm? So dm is nothing but, what is the dl? That is the length, short length, r d theta into that particular density, that is linear mass density m naught. So m naught into r d theta. F is k into delta x. So if I just equate it, I get directly the equation of v square, which is k into 2 pi r minus L by m naught. That's it. Only the short two procedures. First thing, we have to find the extension. This is simple free body diagram. Question number 2. Two identical ring of equal mass m and radius r rigidly attached wears a bead of mass m. Bead can freely slide without friction. It is hinged at a point P in such a way that it can freely rotate about horizontal axis passing through point P. The ring and bead are released from rest from given position. Then just after release. So this is a very important point, just after release. Okay, there is an axis which is going inward at this particular point P, and these two are, let's suppose, welded, that is rigidly attached, and the bead is free. Okay, if you see, observe the motion completely, what happens is this whole system, due to the mass imbalance, okay, it will, this whole part will move in this direction, and finally you get something like this, where point P is here, and the bead will anyway move in this direction, right? Okay, these are the conclusions. First, let's write the torque about the point P. If you see here, I'm considering these two are as a single system, a single body, and this bead is simply attached with it. Okay, I'm not considering is in it as a part of system because it moves relative to this, right? Okay, if you see, the bead experience some sort of normal reaction in this direction, so that at last it comes to a position here. Okay, anyway, downward due to gravity, and there is some force which is responsible for taking it to the left. That is the normal reaction here. So if I draw the free body diagram of the bead, I get normal reaction to the left and mg to a down. Okay, now the same normal reaction the bead will give on this system in the rightward direction. So if you see, n is acting here, and this is the points that I have marked. Okay, now what are they asking? Magnitude of angular acceleration of the ring and magnitude of acceleration of bead. Simple. Let's first write the total torque acting on the system. Okay, why am I writing it? Because the path is not clear on how to solve this particular question. So let's first start with what we have. So total torque acting on the system is this mg into 2r, okay, minus this thing is produces clockwise torque, and this normal reaction n produces anti-clockwise torque, and the torque due to this is 0 because it passes through the line joining the axis. So minus n into r. So this is the total torque. So what is the total moment of inertia of this particular system? So for this, it's mr square, and we are displacing it by perpendicular parallel axis theorem. We get again mr square, and similarly for this mr square and by parallel axis theorem m into 5r square, because this is 2r and this is r. So 2r square, that is 2r the whole square plus r square, so we get 5r square. So on overall we get 8mr square as the total moment of inertia of this whole system. If I apply, torque is nothing but the I alpha. There is no other torque, right? Okay, so we are going to apply I alpha. So I get 8mr alpha is 2mg minus n. Now you may ask, what, you have another unknown quantity alpha and n, two unknown quantities, and you don't have that much equations. How are you going to link that? There comes a point when these two things are in contact at that particular instant, their accelerations in x direction are same, right? The acceleration of bead in x direction as well as the two ring weldment. So the acceleration of bead in x direction is n by m, correct? The same acceleration is given for this system in x direction. So that is, the whole system in x direction experiences r alpha, right? So x direction, in this direction the acceleration is r alpha, because the acceleration should be perpendicular to the radius. So it's r alpha. So what I get is, let the acceleration of bead be a, then ax is n by m, which is r alpha, that I have explained. So 8m into n by m. I am substituting this particular relation, n by m is r alpha here. Okay. So what I get is n is 2 by m into mg. So I found out normal reaction. Then what is alpha? Just divide by m. 2 by 9 into g by r. That's it. I got alpha. What about the a? So I know ax and ay is nothing but g. So directly I can find under root 85 by 9 into g. Very simple, right? So the same concept as used in the previous videos, we have simple tools in physics to solve all the complex problems. If you start with what you have and assume what you need, you get what they require. Let's go to question number 3. Two disks A and B, each of mass 2 kg and radius zero point 0.5 meter, are rigidly fixed to ends of a thin shaft S, which is supported in horizontal position with the help of two smooth bearings at point P1 and P2. Two blocks of masses 2 kg and 1 kg are connected to the light cord wrapped around the discs as shown in the figure. There is no slipping between the cords and the discs. If the system is released from rest from the position shown, then mark the correct statements where G is 10 meter per second square. So these are all the statements first. Okay. Now this whole diagram seems something like complex. You don't understand it easily. Let's simply visualize. So we have two bearings at 2 points where here and here at P1 and P2. People used to get confused by seeing these many numbers, or sorry, these many markings P1, P2, A, B, S, and all. Just be chill. So these two bearings, and I have a weightless shaft, so it doesn't have any moment of inertia, in which I have attached two discs. So this whole thing is a system. A, B, and S is a system. So these three things should be considered as a single rigid body. Okay, and then there's a pulley, which is, these things are a pulley. Suppose I'm just attaching threads on both sides with, this is the blocks of mass 2 kg and 1 kg attached, as both are identical. This, of course, this 2 kg will go down and this 1 kg will go up, and the whole system will rotate in this direction. Layman things, right? Okay. And they have mentioned there is no slipping. Okay. So the work done by this particular string on this part is negative. So power delivered by the string to the connected to the 2 kg block is negative. That's correct. So let's take it. That option is correct. So what about the next one? The next one is magnitude of acceleration. Okay, the total work done by tension on the discs is zero during the motion. This is only true because when these two masses are equal and there's no motion. But in this case, this 2 kg goes down and this 1 kg goes up. Okay, of the same distance. So there is a work done here due to gravity. So this is completely wrong. These two tell about the acceleration. Let's find it out in few steps. So the thing we know, the total moment of inertia of system without considering the shaft, because the shaft moment of inertia is zero. And these two are disks of same radius and same mass, so mr square by 2 plus mr square by 2, which is mr square. And for this 2 kg, there is a T1 acting upwards and a 2g acting downwards. And for this, T2 is acting upwards and g acting downwards. As the whole system has an angular acceleration alpha, and these two are identical, the r alphas are same, so we get same a. So for this, the a is downwards, for this, the a is upwards. So if I write the new NLM equation, so 2g minus t1 is 2a, t2 minus g is a. If I simplify, do some math stuff, I get 4g equal to 2t2 plus t1. This is the equation 1. So anyway, to find the acceleration, we want at least one of these, that is t1 or t2. We have a relation between them. So let's go to the next equation, which is torque equation. So total torque is T1 minus T2 into R, which is T1 minus T2 into R is nothing but mr square. So m is 2 and r square into alpha, I alpha. So r gets cancelled and r alpha is nothing but a. So T1 minus T2 is 2a and T1 minus T2 is 2g minus T1 from this equation. So if I simplify, what I get is 4t1 minus 2t2 is 4g. So I have two equations involving 4g. If I simplify, I can get the relation between t1 and t2. That's it. If I substitute it in any of the equation, that is 1 or 2, I get t1 is 8g by 5 and t2 is 6g by 5. And if I substitute this in any of these two equations, I get a is g by 5, which is 2 meter per second square. So option 2 is correct. So these are very much simple questions, right? If you see the solution, you see it's very much simple. But if you read a question in your exams, you get some slightly confused because of over complexity. Okay, here are we to help you simplify questions, break down the complexities. Thank you for following us. Do watch our previous videos. Kindly subscribe our channel. Thank you for watching this video.